So this is lesson number 22 in Algebra 2, uniform motion problems, equal distances, and similar triangles and proportions. Key thing you want to remember when you're doing motion problems is distance equals rate times time. So the distance you go, you're able to find that by taking your speed times how long it takes you. So if you are going 30 miles per hour for 4 hours, you have just gone a distance of 120 miles. So that's what we're going to look at. So if we have the distance going to somewhere and we leave, so let's say that you're going from your house to Anchorage. So you're going from your house to Anchorage. And let's say that's 150 miles. And then you go from Anchorage back to your house, you've also got 150 miles. Doesn't matter how fast you went and how long it took you, you went the same distance. So the distance to Anchorage equals the distance from Anchorage. So D1 equals D2. And remember, we found D1 to Anchorage by taking the rate, the speed going to Anchorage, times the time it took us to get to Anchorage. To find D2, our way home from Anchorage, we took the speed going home times the time it took us to get home. So if D1 equals D2, then R1 T1 equals R2 T2. Sounds like a math Star Wars movie. R2T2. Okay, so anyway, that's what we're going to be using in our problem. If the distances are the same, then when we multiply the rate times time, they're going to be equal as well. And that's going to be very, very important to remember as we're doing these. So let's get started with an example. Roger made the trip on Sunday and Judy made the same trip on Monday. So the distance Roger went and the distance Judy went are the same because they made the same trip. It was just 2 different days. Roger traveled 12 miles per hour. So Roger's rate was 12 miles per hour. Judy's rate, the rate of Judy, was 20 miles per hour. So her time was 2 hours less than Roger's. So Judy's time was 2 hours less than Roger's. So if we wanted Judy's time to be the same as Roger's, we would have had to add 2 hours to her time, right? To make it the same as Roger's. Because if hers was 2 hours less, so let's say, for example, let's use numbers. Let's say it took Judy 6 hours. Well, how long did it take Roger? Well, Judy was 2 hours less, so it would have had to have taken Roger 8 hours. Well, if I'm going to make them equal, I have to add those 2 hours to Judy's time in order to make it equal to Roger's. So that's why I wrote this up here like I did. If I want them to be equal, because they aren't equal, are they? Judy was 2 hours earlier or faster than Roger. So to make them equal, I had to add that 2 back to Judy's. I had to slow her down so that she could be the same as Roger. Okay, and so the time it took Roger was T of R, time of Roger. All right, so I know that the time, or the distance, for Roger was the same as the distance for Judy. One went faster than the other, but the distances were the same. So I could say the rate of Roger times the time of Roger equals the rate of Judy times the time of Judy. Because remember what I had on the past screen. If D1 equals D2, then the rate of the one times time equals the rate times time of the other one. And that's what I did right here. Alright, so I've got this bit of information that's very important for me to have here. So let's start filling in the blanks. I have the rate of Roger is 12. TR, what does TR equal? TR equals TJ plus 2. I'm going to put that in there. Time of Judy plus 2 equals the rate of Judy. Rate of Judy is 20. And what is the time of Judy? Time of Judy. It's just going to be the time of Judy, right? Because notice what we did is, instead of writing the time of Roger, I substituted this in for TR. So that means we don't have two different T's here. We don't have a T of R and a T of J. We made this a T of J plus 2. So now we only have one variable. T of J, one variable that occurs twice. So let's go ahead and multiply. Subtract 12. And we have 24 equals, because those cancel, 20 minus 12. Divide by 8. Divide by 8. So the time of Judy is going to be 24 over 8, which is 3. Okay, so the time of Judy was 3. The time of Roger would have been Judy's time plus 2. So the time of Roger is going to be 5. But here's the problem. That's not what we're looking for, is it? We found out the time, but actually we're trying to find how far they traveled. Well, what do we know about distance? We know distance equals rate times time. What do we know? We know their rate from up here. And now we know their times. So all we have to do is take Roger, for instance, to find out how far he went. We take his rate, 12, times his time, 5, and we get 60. If we would have taken Judy's, it would have been her speed, her rate, times her time, and that would also be 60. So it doesn't matter which of the two you do, the distance of Roger or the distance of Judy. When you put them together, you're going to get the same number here anyway. Okay, so let's look at 22.2 and be done with the word problems here.